9.4 Special Right Triangles. There are two special right triangles. We'll start with the 45, 45, 90 triangle. If you remember from previous lessons, when we have a triangle that has angles congruent, but the sides opposite those angles are congruent also. In the 45, 45, 90 triangle, the sides opposite these angles are our legs. So in the 45, 45, 90 triangle, the legs will always be congruent to each other. The third side, the side across from the right angle, is our hypotenuse. What we want to learn is how to find that hypotenuse. So let's say that one leg is equal to x. Then the other leg is also equal to x. How can we find our hypotenuse? Remember your Pythagorean theorem. C squared, which is the hypotenuse squared, is equal to a squared plus b squared, where a and b are your legs. The hypotenuse is what we want to find, so we'll use h for the hypotenuse, and we know each leg is equal to x, so we would have x squared plus x squared. Put like terms together, then h squared would be equal to 1x squared plus 1x squared would give us 2x squared. We want to get h by itself to find what the hypotenuse would be equal to, so we would have to take the square root of both sides. The square root of h squared would be equal to the square root of 2x squared. On the left-hand side, the square and the square root cancel each other out, so the square root of h squared would just be equal to h. On the right-hand side, we have the square root of 2x squared. The square root of 2 cannot be simplified, but this x squared, we can take the square root of x squared, and that would be equal to x. The 2 would have to stay under the radical. So what we see is, if the leg is equal to x, then the hypotenuse is equal to x times the square root of 2, or the length of a leg times the square root of 2. That brings us to the rule for the 45, 45, 90 triangle. In a 45, 45, 90 triangle, remember, the legs are congruent. To get the hypotenuse, you would take the length of a leg and multiply it times the square root of 2. So one of our special right triangles is the 45, 45, 90. The other is the 30, 60, 90. What I'd first like for you to see is that a 30, 60, 90 triangle is half of an equilateral triangle. Let's draw the other side of the equilateral triangle and look at the equilateral triangle first. Remember, on an equilateral triangle, all three sides are congruent to each other, and all three angles are congruent to each other, making them all three 60 degrees. So we have an equilateral triangle, all three sides congruent, and all three angles 60, 60, and 60. Now, to get to our 30, 60, 90 triangle, which is what we want to look at today, we would draw the altitude in the equilateral triangle. That altitude in the equilateral triangle cuts this equilateral triangle into two right triangles, where you have a right triangle on the right side and a right triangle over on the left side. Notice in these two right triangles that the hypotenuses are still congruent to each other. Right triangle on the left, right triangle on the right, hypotenuses are congruent to each other. Let's look at the relationship now between the hypotenuse and this side across from the 30-degree angle. The side across from the 30-degree angle is a leg, and it would be what we would call the short leg, since it is across from the shortest, smallest angle. When it was an equilateral triangle, the whole side over here would have been congruent to this whole side, but now this altitude has cut it into two equal parts, so that this short leg of the 30, 60, 90 triangle is congruent to the short leg of this 30, 60, 90 triangle. So it has split this whole side into two congruent pieces. For instance, if the hypotenuse over here were 14, then this hypotenuse would also be 14. Now the two short legs down here, they would both be half of that 14, or each equal to 7. So that brings us to the very first rule for our 30, 60, 90 triangle. In our 30, 60, 90 triangle, the side across from the 30-degree angle would be our short leg. The side across from our 60-degree angle, this would be our long leg. And the side across from our right angle would be our hypotenuse. What we've just learned is that hypotenuse would always be twice as long as the short leg. So we can move back and forth between the short leg and the hypotenuse by multiplying and dividing by 2. If we know the short leg, to get around to the hypotenuse, we would multiply by 2. To go backwards from the hypotenuse around to the short leg, we would divide by 2. What we want to learn now is how to get from the short leg around to the long leg. The short leg in a 30, 60, 90 is what I tell my students, the door. From the door, you can go either direction, around to the hypotenuse or around to the long leg. To go from the short leg around to the long leg, you would multiply by the square root of 3. To go backwards from the long leg to the short leg, you would divide by the square root of 3. Keep in mind, the short leg is the door. From the short leg, you can go to either side, either to the hypotenuse or to the long leg. From the short leg, you can go either direction, to the hypotenuse or to the long leg. You can never go straight from the hypotenuse to the long leg or from the long leg to the hypotenuse. Not allowed to do this. If you are ever given one of the other sides, the long leg or the hypotenuse, you must first go backwards from there to the short leg. Let's look at the rules for the 30, 60, 90 triangle. On a 30, 60, 90 triangle, if you want to find the hypotenuse would be equal to 2 times the short leg. If you're looking for the long leg is always equal to the short leg times the square root of 3. Now let's look at a couple of examples. In this example, notice first that you have a 45, 45, 90 triangle. Remember, in a 45, 45, 90 triangle, the legs will always be congruent to each other. One of your legs you're given, it's 4. The other leg is congruent to that, so x would be equal to 4. No work required. Now what we need to remember is, how do we get from a leg around to the hypotenuse in a 45, 45, 90 triangle? Remember, y is your hypotenuse, since it's the side across from your right angle. And in a 45, 45, 90, to get from the leg to the hypotenuse, it's a leg times the square root of 2. Since we know the leg is 4, and the hypotenuse would be 4 times the square root of 2, done. Let's look at another example. In this example, notice that you have a 30, 60, 90 triangle. It is important to realize which sides are which. You're given this side 10 square root of 3. It's important to notice that that is across from your 60-degree angle, making this the long leg. As we discussed previously, the only place you can go from here is around to the short leg. The short leg would be the side across from the 30-degree angle. The short leg would be A. To go backwards from the long leg around to the short leg, you must divide by the square root of 3. So A is the short leg, and we know the short leg would be equal to the long leg divided by the square root of 3. Since the long leg is 10 square root of 3, we would divide that by the square root of 3. The square roots of 3 would cancel out, and we would find that A, the short leg, is equal to 10. Now, we still would like to find the hypotenuse. Then we want to move from the short leg around to the hypotenuse. B is your hypotenuse. And we know in the 30, 60, 90 triangle that the hypotenuse is equal to the short leg times 2. We've just found that the short leg is 10. Multiply that by 2. Find that your hypotenuse is 20. Let's look at another example. In this example, first we should recognize that we have a rectangle, and in that rectangle they've drawn a diagonal. That diagonal has split the rectangle into 2 right triangles. Because this angle is a 60-degree angle, in this right triangle, the third angle must be a 30-degree angle. So we have a 30, 60, 90 triangle. Since we know the side across from the 30-degree angle, that would be our short leg. Okay. The first side we want to find is our hypotenuse in. Remember, in a 30, 60, 90 triangle, the hypotenuse is always equal to 2 times the short leg. So n is equal to 2 times the 15. N would be equal to 30. Next, we want to find m. The first thing to realize is that this is a rectangle, and in a rectangle, opposite sides are congruent. On our 30, 60, 90 triangle, this is the long leg. So m is equal to our long leg. Remember, in a 30, 60, 90 triangle, to find the long leg, it's the square root of 3 times the short leg, or the short leg times the square root of 3. In our 30, 60, 90 triangle, we know the short leg is 15 times the square root of 3. We end up with the length of m is equal to 15 times the square root of 3. Let's look at something a little bit more complicated. In this diagram, we have 2 right triangles connected. On the left-hand side, we have a 45, 45, 90 triangle. And on the right-hand side, we have a 30, 60, 90 triangle. We're given only one side and expected to find all of the other sides. Let's begin with the 45, 45, 90 triangle. In the 45, 45, 90 triangle, we know one of the legs. Remember that the legs in a 45, 45, 90 triangle are congruent to each other, so A would be equal to 12. Now we want to move from a leg around to the hypotenuse. Remember, to move from a leg on a 45, 45, 90 triangle to the hypotenuse, we would multiply by the square root of 2. Therefore, B would be equal to the length of the leg, 12, times the square root of 2. The 45, 45, 90 triangle has been solved. Now let's move over to the 30, 60, 90 triangle. On the 30, 60, 90 triangle, we know just this one side. It is the side across from the 30-degree angle, making this the short leg. When I move from the short leg first around to the hypotenuse, remember to move from the short leg to the hypotenuse, multiply by 2. So C would be equal to 2 times the short leg. C would be equal to 24. Now let's move around from the short leg to the long leg. Remember, in a 30, 60, 90 triangle, to move from the short leg to the long leg, you multiply by the square root of 3. So D would be equal to 12 times the square root of 3. One more piece to find, and that would be E. E would be equal to piece A plus piece D. Therefore, it would be equal to 12 plus 12 square root of 3. Without turning this into a decimal answer, this would be as simplified as you could go. But you could punch it into your calculator. 12 plus 12 square root of 3. Turn it into a decimal answer and find that E would be approximately equal to 32.8. There we have it. Hope this was helpful.